Next one step. Let's start from, we are going to the determinants thing. First one, determinant and all the matrix. And today we have only the very basic definition, basic concept of the determinant matrix. I want to show you where it from arises. There it from arises. There it arises from. And today I'll give you the very concept of this determinant. I want to show you where it arises from. For example, you have 2x2 situation, two equations, and two unknown variables. I here want to write down the very common view of this system of equations. A 2 1 x1 plus a 2 2 x2, this equal b1, this one equal b2. At school we can make a substitution. We can use the substitution method, and we can express x1 from for example from the very first equation through the other one part and through other unknown variable. So according to this next step, according to this notation, we have that x11 equal b1 minus a12 x2 divided by the a11. Now I can put this x1 into the second equation, and I express this expression for x2. I have a21 times b1 minus a12 x2 over a11. This is the x1 plus a22 x2 equal b2. I have x2 at two term here, so I can express these x2 together. I can gather together with them. I have a 22 x2 minus a21 a12 times x2 over a11. And I want to move all elements or free elements with respect to unknown variable on the right side of this equation. I have b2 here, and I have a21 times b1 over a11. I have to move on the right side. 1b1 a11. Now I have to add the left side to the common denominator a11, and I have a11 times a22 x2, here it is 2 here, minus a21 a12 times x2, and I have here the common denominator is a11. On the right side I have a11 b2 minus a21 b1 over a11. A11. I can cancel A11. Cancel. And I can express x2 through other numbers. Since that x2 equal a11b2 minus a21b1 over a11 a22 minus a12 a21 a12. That's all. Okay. So now I want to delete all of these one inferring, and I want to write down only the answer. Okay, if you don't mind. Duplicate. Okay, so x1 consequently equal, I have to put here x2, and I have x1 equal b2 a22 minus b2 a12 over a11 a22 minus a21 a12. Okay, that is your home assignment if you want to have your the best final grade. You have to complete this home assignment, one of the work. Don't think that it is the only work to get the excellent grade. Prove it. So prove it. So infer that x1 is really equal to this quotient of two expression. X1 is x2, they have the same. Let's make one example firstly. An example here. Example. For example, I have an equation like 1x1 minus 2x2 equal 3, 2x1 plus x2 equal 5, for example. So we have this system of equations, and the first step here, let's transform it into the matrix form. It is a11 equal 1, a12 equal minus 2, so we can notice that we use these coefficients or factors, a21 2 and a22 1. Now x1 x2 here, and B matrix 3 5. Okay, now we can use these formulas for x1 and x2. Let's calculate x2. B2 here, B2 equal 5, so 5 times a11 here in this matrix, it is 1 minus a21 a21, the second row and the first column, it is 2 times b1 3 over a11 1 a22 1 minus A21, it is 2, A12 minus 2. And we have 5 minus 6 over 1 plus minus and minus multiplication gives plus. It is 4, 1 plus 4, 5, and it is minus 1 over 5. And x3 equal x3, x1 equal, and x1 equal, we can use the second one formula here, b1, which is 3 times a22. A22 gives 1 minus b2, 5 times a12 1 a12 y1 times a12, the first row, the second column, it is minus 2 over, you can notice that for both of them, x1 and x2, the denominator is the same, so I can take these 5, and I have 3 plus 7, it is equal 3 plus 10 minus and minus 13 over 55. And what do we have? Let's check. Is this correct? If we have correct answers or not. We can put this x1 and x2 into the given equation. So we have x1 minus 2 over x2 is 13 over 5 plus 2 over 5, it is 5 over 5, and it is 3. And we can put at the next one equation 2x1, it is 26 over 5 minus, yes, that is correct. So we have correct answer. What do we have here? We have very important result here. This expression, if I put down this matrix form, A equal A11, A12, A21, A22, you can notice that A11, A22, it is the multiplication of the diagonal elements. I use the red ink here. A11, A22, and it gives positive term here, and A21, A12 is a result of the product of the inverse diagonal. I use this blue ink, and it goes with sign minus here. So this one expression is named determinant of the 2 by 2 matrix, and we have here determinant A, determinant A. Sometimes we can denote determinant A like using the same matrix form, but we have to here parentheses, but for determinant we use the vertical lines as a bracket, and we have here A11, A12, A21, and A22, and it gives, I use one more again here, different inks, A11, A22, minus A12 A21. This expression is known like a determinant of the matrix. Determinant of the matrix. Okay, and by the way, this is the formula to calculate determinants of the matrices. These 2x2 matrices. Determinant of the matrix 2x2. Don't use the formula for matrix with size which is superior to 2x2 matrix. Okay. Determinant. And we have very important category from this calculation. If I can use this green ink here, red ink here, because it's very important. If determinant of A equals 0, there is no root of the system of equations. Okay, and the very last thing, example. As always, I very like to make some examples. Slow. Example. I use this blue ink. Example. So you have given system of equations 2x1 minus 3x2 equals 7, for example, and for example 4x minus 4x1 plus 6x2 equal 1, for example, and you want to calculate the roots. Calculate roots of the equations, of the system of equations, linear equations. And the very first step here, we have to transform this one system of equations into matrix form. So we have A equal 2x1. Oh, I'm sorry. At me. 2 minus 3 minus 4, 6. X equal x1, x2. It is all x1, x2. You even shouldn't write down the x matrix because it's clear. And B equal 7, 1. So the first one step here, we have to calculate determinant of the A. I use this matrix form of the minus 3 minus 4, 6. You remember that we have to use this formula, diagonal formula, 2 times x minus this one opposite diagonal elements multiplicated. I use this, and it is equal 2 times 6, and I use the blue ink. You shouldn't use different colors, I just want to explain you. Minus 3 times minus 4, and we have finally 2 times 6 12. 3 times 4, 12, but we have minus 3 minuses. We have odd number of minuses, and that leads to the minus, gives minus 12, and it is 0. That means the system of linear equations doesn't have solution. So you can stop your calculation here because you have a result. Goodbye. See you next time.